We're now going to continue our discussion of section 7.1, where we will talk about verifying trigonometric identities. The book gives us several suggestions as to how to start a problem. The first suggestion is that we work with one side at a time. It tells us to choose one side of the equation to work with and simplify it. The more complicated side is usually the best choice. Your goal is to transform one side into the other side. The second guideline is to apply trigonometric identities as appropriate. To do so, it will probably be necessary to combine fractions, add or subtract terms, factor expressions, or use other algebraic manipulations. And our third guideline tells us to rewrite in terms of sines and cosines. If you are stuck, expressing everything in terms of sines and cosines often leads to inspiration. So let's begin with an example. Our example asks us to verify the identity 2 cosecant squared x is equal to 1 divided by the quantity 1 minus cosine x plus 1 divided by the quantity 1 plus cosine x. We're told in our guidelines to start with the more difficult side. So we're going to start with the right. So I'm going to write my right side down. And remember that our goal is to turn this side into 2 cosecant squared x. Now, using our guidelines, we're told to make sure everything is in terms of sines and cosines, which it is. We're also told to maybe use algebraic manipulations. We saw in the last two examples in the previous presentation that one thing we often used was a common denominator. So let's try that here. So remember that our denominator needs to be the product of the two current denominators. So our common denominator will be, I'm just going to jot it up here, 1 minus cosine x and 1 plus cosine x. So that's taking our two denominators and putting them together as a new denominator. Now, when I look at my fraction, when I look at my first fraction, I notice that I already have the 1 minus cosine x, so that part's done, but I'm going to need this part, the 1 plus cosine x. So I'm going to multiply both sides of this by 1 plus cosine x, or I'm sorry, top and bottom, by 1 plus cosine x. Okay, so when we look at our second fraction, and we compare our denominator, we have the 1 plus cosine x, so we have that part, but we're going to need that part. So we're going to multiply this one, top and bottom, by 1 minus cosine x. Okay, so let's go ahead and do that multiplication. So for the first set, we're just going to multiply 1 times 1 plus cosine x. And on the bottom, we'll have our new denominator. And I'm not going to multiply this out until I feel like I need to. All right, for my second fraction, I have 1 times 1 minus cosine x. And again, we have our new denominator. So now that our two fractions have the same denominator, we can move the two fractions together and write it as one fraction. So I'm going to have 1 plus cosine x plus 1 minus cosine x all over the new denominator. All right, so continuing to simplify, we notice that on the top, the cosines cancel out. We have a positive cosine and a negative cosine. and the 1 plus the 1 makes 2. So we have 2. And now I'm going to go ahead and multiply on the denominators. Now I'm going to do FOIL method, so I'm going to do first times first, which will be 1. The outside terms, 1 times positive cosine. The inside terms, negative cosine times 1. And the last two terms, which will be a negative cosine squared. So our middle terms again here will cancel. We have a positive cosine and a negative cosine. So I now have the 2 on the top, and I have 1 minus cosine squared on the bottom. Now, there's a technique that we'll see playing out repeatedly in problems with a denominator like 1 minus cosine squared. And what that technique is we're going to take this Pythagorean identity that we have, sine squared plus cosine squared is equal to 1, and we're going to manipulate it so that we have 1 minus cosine squared on one side. So what I'm going to do is I'm going to subtract the cosine squared from both sides. So that gives me sine squared x is equal to 1 minus cosine squared x. So what that tells me is that this denominator, this 1 minus cosine squared, is the same thing as sine squared. So I'm going to go ahead and put that in. And so remember, we have an identity that says that 1 over sine is equal to cosecant. And so we're going to use that identity here. Now I'm going to go ahead and pull this 2, which is a constant, to the front, which will leave me 1 over sine squared x. Now this identity will hold if we put a squared on the sine, as long as we also put a square on the cosecant. And so 1 over sine squared is going to equal cosecant squared. And so that completes our problem, because what we have done is we've taken the right-hand side of the problem up here, and we've now turned it into 2 cosecant squared x.